Good day to all my metric friends, wherever you may be. It's once more that time where we come together to discuss content related to metric exam. Right. May I render my appreciation to those who are liking the videos, those who are supporting this video, just to encourage, just even the words of encouragement, that it really, the videos are of great help. It actually means a lot. Don't forget also to make a comment where you make suggestions to see where we can actually improve, right? So today, friends, we'll be looking at genetics once more, but primarily focusing on excuse me, on determination of gender or sex. Determination of sex of a child. Determination of sex. Now, what we mean here by sex, we are talking about the gender of a person. What determines the gender of an individual? Right. So, I want to bring to you understanding, friends, that the gender of a child is determined by both the father and the mother, or male and the female. So now, before we go to look at the genetic cross, as in how this occurs, I would want us to look at this scenario. Okay, so we all remember that in the gonozome are the sex chromosome, right? In females, remember, in their genotype, females have 46 chromosomes, or I would say they have 22 pairs of chromosomes, right? So, which are autosome. However, you know that when a gamete in a female actually forms, usually there are 22 single chromosomes on each position in the karyotype, right? Plus the X chromosome. Don't forget that the female has XX chromosome. So when the gametes form, they usually have a gamete or a ovum, which is going to have 22 chromosomes plus the X chromosomes, always. So, in other words, female have got only one type of sex cell, which has got the X chromosome. Okay. Now, what about in males? When we talk about males have got two types of sperm cells. Here is the sperm cell, right? The sperm cell here in the nucleus, it may have 22 autosomes plus the X chromosome, because remember, the father has the X and the Y in his gonosome. Well, remember, he indicated the father has got XX, right? So this is a diploid cell, and that is a diploid cell. So when it undergoes meiosis, there are 22 autosomes that are going to be produced plus the sex chromosome. As you can see, this gives us a total of 23 chromosomes altogether in the nucleus. Now, in a male, there are also X and Y on his gonosome. So meiosis, when it occurs, the 46 chromosomes, they are going to be reduced to form the haploid cell, which is the sperm cell. So there are two types of sperm cells that a male can produce. It will be one that may have the X chromosome, or he can actually produce another sperm cell, which is going to have 22 autosome plus the Y chromosome. Can you see that? So this is what makes us, we males, as unique, because we have X and Y. So it's either a male can release a sperm cell that fertilizes the ovum, which has the X chromosome. It may have the X chromosome, but at times it can release another sperm that may have what? The Y chromosome. So that is the difference. Very important. Now let's look at this. How is gender determined in this essence? We all know that by this time we know the generic presentation of the genetic cross. I'm sure grade 12s, you should be familiar with the generic expression of the cross, where we begin with the phenotype, right? Phenotype, then we have the genotype, we have meiosis, which is a process that takes place. Then meiosis gives way for gametes to form. So we're going to have gametes. So then we're going to have a fertilization following the gametes. Fertilization is another process where the sperm cell fuses with the ovum. Then we finally going to have the F1 generations. So with the F1 generation is going to have the genotype, and we'll have the phenotype. Right, very important, guys. Now let's look at how this. Don't forget to actually mark these two because they're very important, as well as the meiosis goes with fertilization, while the P1 goes with the F1. Always you indicate that. Now let's look at the determination of gender in this case. We all know that here we are talking about sexual reproduction, right? So in sexual reproduction, we have the father who is a male. Now cross, who is married to the mother who is a female, right? So the genotype of the father is XY, like I indicated. So they cross with the female. The female always represents the XX chromosome, right? So when meiosis occurs in these two individuals, they are going to give us how many? They are going to give us 4 gametes. They are going to be 4 gametes. Now, if you remember, in my previous lesson, when we were talking about Mendel's second law of segregation, or just say Mendel's law of segregation. Mendel's law of segregation states that an organism has 2 factors. There are 2 factors then, and this one has got 2 factors which segregate. So then, remember, segregation is separation. The other one goes that way, the other one goes that way. So which segregate so that each of the gamete that is produced is not going to have 2, but is going to have 1. That is why we've got to, this factor goes there, and this factor goes there. That factor goes there, and that factor goes there. Remember, these factors, as Mendel indicated, or named them as such, in other words, the factors are alleles. I guess you're familiar with that. So now let's look at what happens is there's going to be a cross that's going to take place, whereby during fertilization, it may happen that this X from the father, X chromosome from the father, may fuse with that X, which is going to give us 2X that way. Or it can be again this X from the father fusing with that X from the mother, so which is going to give us XX that way. So again, it can be that Y from the father and that X from the mother. So what is going to happen here? So you're going to have X and Y. So I'm not writing Y first. I'm to write the X chromosome first before I write the Y, because as you know, X in the alphabet comes earlier than the comes earlier than the Y chromosome. That's why we write X. But however, it is still correct even if you write with Y first, right? But it makes much more sense when you write XY, right? So let's look at this here now. So it can happen again, that Y chromosome crossing with that, of which is going to give us XY. So if you look at what is happening here, you've got one X, you've got two XX and two XX, which actually in the phenotype translation is going to give us two females. So there are two females here, right? So it can happen that these are also the same. The XY here, there are two. So we're going to actually to combine them, just say two males. So you know that males are XY. So we have how many males? We have two males and two females, of which if we are to determine the ratio in this case, it will give us it will be 2:2, which gives us 1:1. As you know that the ratio should always be simplified. You don't leave the ratio hanging. So always you simplify it in its simpler terms. So this is what actually happens. Now, the other very important thing that I want you to remember is that right. Another very important thing is that you must always remember that what is the percentage chance of a child each time a mother actually falls pregnant? What is the percentage chance of the mother having a child who is a female, right? So you can remember from the genetic cross that we're doing, we saw that there were two females, right? So out of 4, we have 2 females, of which we're going to say 2 divided by 4, of which times 100. So meaning that the percentage chance that is going to be 50% chance that the child will be born a female. What about that to be born a male? Similarly, how many males were there? There were 2. Remember, the ratio was 2:2, and we simplified it into 1:1. So we're going to say 2 divided by 4. We say times what? 100. So this also gives you it gives you 50 percentage chance of a child being born a male. So if they're asking you what is the chance that a child can be born a male, it is always 50%, and to be born a female is always 50%. So very important. Now, who determines the gender of the child? Now, the father determines the gender of the child. Why are we saying the father determines the gender of determines the child to be born a male? Father determines or rather the gender of the child. The gender of the child is dependent on the type of sperm cell. Remember I said there are two sperm cells. Sperm cell from who? From the father. From the father. How possible is this? If the father releases the X chromosome, the child will always be a female because the mother will always release the ovum with the X chromosome. So if the father releases the Y chromosome, then the child is going to be a male because now the Y is only released by the father and not the female. So, however, it is not a choice for the father to say this time around I want to release the sperm cell with the Y chromosome, as this activity, it happens on its own without the man knowing, or has no control over it. So that is about determination of gender. I guess you'll be able to explain this question. So say in an exam they say use a genetic cross to determine the gender of a child. Or they may say a woman has got 6 girl children. All the children are girls. Then she's pregnant for the 7th child. What is the percentage chance of the child that will be born, the 7th child, being a male? Now remember, it doesn't matter how many times the mother has been pregnant. The mother may have many children with the same gender, but each child is independent of the other. So the percentage chance of a child being born male or female will always remain 50-50%. It will always remain 50-50%. Thank you guys. See you in the next lesson.